All right, guys, welcome to 11.3, part 2. We are going to be finishing up lesson 3, which we didn't do last time. So last time we looked at solving equations using calculators instead of the unit circle. And so we did that with cosine and secant. We did it with sine and cosecant. Today we're going to look at sine and cosecant again, but this time negatives are going to come into the picture. Whenever these functions equal negative things, we have an extra step to consider here. Finally, we'll close out with equations involving tangent and cotangent. So that is the goal for today. So let's review our steps about solving equations with sine and cosecant. If there's a cosecant, we're going to change it to sine by taking the reciprocal. Then we're going to use our calculator and the arcsine function to find one of our answers, which will be on the right half. And then we're going to sketch the angle. So let's say it was here. And that we already know one answer, and we know the other one would be somewhere over here. And we use symmetry to find the other answer in the left half. Now, today, though, we're going to be looking at angles that would be down here instead. And we have to do something a little bit interesting with those, and you'll see what they are and why in just a moment. So, a note about arcsine. Arcsine will only give solutions for the right half of the unit circle, as you guys know already. But when it gives answers on the lower right half of the unit circle, they're not going to tell you the angles that we're used to seeing. They're going to give you the negative angles. So what do I mean by that? Well, let's say we end up with an angle down here. When our calculator is going to tell us that that's negative 45 degrees. Okay, so they're not going to tell us that it's 315 degrees, even though these are really the same angle. They're coterminal. It's going to give us the negative angle. So we're going to have to convert the negative angle into the regular angle so that we can find the other side after that. Okay, so that's the thing. Arcsine, whenever it gives you answers down here, will give you the negative version of those angles. It will not give you the angles that are actually on the unit circle. So we need to convert those to positive angles by adding 360 to it. Okay, so that will be the first set that we look at. So let's go ahead and begin here. We have sine of theta is equal to negative 0.822. So step one is to change cosecant into sine, but we can skip that because it's already sine. Step two is to use our calculator. So first thing I'm going to do is I'm going to get rid of the sine on the left side, so the theta is by itself. I'm going to put arcsine on the opposite side. And then from here, I'm going to get out my calculator and figure out what that is. All right, the answer we get there is negative 55 degrees. Now, we don't want negative 55 degrees, so we have to do a little extra step here, and we have to add 360 to that. So if I add 360 to that, I end up with 305 degrees, and that's going to count as my first answer. Okay. After that, the rest of the problem is the same. So we have one answer, 305 degrees. Now we're going to move on to the next part where we sketch the angle. 305 degrees would be somewhere like over here, we'll say. And we know that that is this angle here. Okay. Now we also know, and this could actually be helpful, we know that this is 55 degrees, right? Because that was the negative angle they gave us at the beginning. So now we need to find the angle over here that's symmetrical to it. So once again, I would encourage you guys to pause the video and see if you guys can figure out what that angle would be. What is the measure of this blue arc from there to there? Okay, so when you pause the video, I'll go over it with you. All right, so here's how I would do it. There's definitely more than one way to do this. If this is 55, because of the symmetry, this is 55. So we know that from here to here is 180, and we know that this part is 55. So if we just add those together, we can get our second answer. So that's how I would do it. There might be another way. Maybe you figured it out too. It doesn't really matter what method you use. There's a few ways to do it, but I get 235. So there are the two answers for that one. Let's go ahead and do number 2 now. Step 1, since it's cosecant, we're going to do the reciprocal on both sides. The reciprocal of cosecant is sine. And the reciprocal of 5.309 looks like that, which is negative 1.88. Then we're going to arcsine both sides of this equation to solve for theta. And in doing that, I end up getting my first answer, which is negative 11 if we round it to the nearest degree. All right. Now, that's not really my first answer though, right? Because I actually need to add 360 to that. So 360 plus a negative 11 would be 349. So that's the one we're going to use. So let me erase that and put 349 there. And there we go. So there's our first answer as a positive angle. All right. Now let's go ahead and find the symmetrical one. So 349 is going to be like somewhere over here. So I know that this angle that goes all the way around here is the 349 degree angle. And I know that this little piece down here between the line and the x-axis is 11, because that's what my first answer tells me. So now I need to find the symmetrical portion, which would be the one over here. And once again, using the symmetry, I would just say, okay, well, that's 11. And then this is 180 plus 11. 191. And there's our second answer for that one. Okay, so we'll let you guys go ahead and try a couple of these real quick. Student practice 3. Pause the video, give these things a try. When you unpause it, you will see the solutions. All right, and so there is the answers. I'll let you guys go ahead and study those. If you didn't get them, consider reworking them until you do. Till then, though, we're going to go ahead and move on to our next set here. We're going to talk about tangent and cotangent. All right. So tangent and cotangent are, in my opinion, a little bit easier, specifically because of the last step where you have to figure out what the other angle is. Tangent and cotangent, it's actually a little bit easier. So let's begin. So first of all, let's say I gave you guys tangent of theta, and I told you that equals 1. So what would the answer be? Well, you could use your calculator if you wanted to, but since this is on the unit circle, I know the answer is already going to be 45 degrees. Okay, but I want to show you guys what the other angle is that also equals 1, because there's another place where tangent equals 1. Do you guys see where else it equals 1? It's right here, and it's at 225. Now here's what's interesting about tangent. It will always be like this. They're always diagonal from each other, and they're always 180 degrees apart. So if you take 45 and you add 200 and you add 180 to it, you get 225. So pick another tangent value like this one, for instance. That's at 60 degrees. If you go diagonal to it, that's where the other radical 3 is. And so the angle that also gives the same answer of radical 3 is 240. And once again, they're 180 degrees apart. So basically, when it comes to tangent, the arctangent is going to give you one answer, and arctangent is like sine. It's only going to give you an answer from this side of the circle. But regardless of which one it gives you, let's say it gave us this one, the other answer will be directly across from it, 180 degrees away. Okay, so let's go ahead and see how these sorts of problems work out. All right, if there is a cotangent, we're going to change it to tangent. Then we're going to use our calculator using the arctangent function to find one answer, and once again, that'll be on the right half of our circle. Now, just so you guys know, tangent is like sine and cosecant, where if it gives you an answer from the bottom right half, it's going to give you the negative version of that, and so we'll have to add 360 to it to make it the positive version. Okay. Then we're going to sketch the angle, and then we're going to use symmetry to find the other answer in the other half. Now, it will be in the left side, but the way that we find this one is that it will be diagonal from our first answer, and it will always be 180 degrees away from it. And so sometimes we'll add through 180 to get to the other angle, or sometimes we'll subtract 180 to get to the other angle. We'll see how that works out as we work through this. So here we go. Let's go ahead and take a look at example 4. So number 1, tangent of theta is equal to 9.147. So this one is not a cotangent, so we can skip step 1, which is where we change cotangent into tangent. And we move on to step 2, and we go ahead and we do arc cotangent on the other side. All right, let's see what we get from that. We get 84 degrees. Now that's going to be my first answer. All right, so the next step is to sketch that angle. So let's go ahead and find where 84 degrees would be at. Where would 84 degrees be located? That would be somewhere like maybe like right up here, pretty close to the y-axis. Okay, now let's see. So now I want to find the other answer. Now the other answer will be diagonal to it. In other words, if you just continue the line straight down, it's not going to be going left, it's not going to be going down, it's going to be going diagonal. And so the other answer will be here, and this is where we get to use some symmetry. Okay, so if this is 84 degrees, right, then this little piece here would be 6 degrees to make 90. This is also 90. And because of the symmetry, if this is 84, then so is this. So the angle that we found was, on the calculator, was 84. And this other angle that we want is going to be 84 plus 6 plus 90 plus 84 all the way around. Okay, so we just need to add all of these numbers up. Let's see what we get. I think I'm getting 264 degrees. Now there's a faster way to do this, to find that second angle, by the way. I'll show you what it is. Let me clean this up, I'll redraw it. But the problem is it's a different for different problems, so I'll show you. But for this one, we know that this is 84 degrees, right? Well, this one is always going to be 180 degrees away from that. So all you have to do is take 84 and add, I'm sorry, not 184. All you have to do is take your angle, 84 degrees, and add to it 180. So that can save you a little bit of time. The problem is that's only going to work on the top half. On the bottom half, instead of adding 180, we're going to be going backwards, and so you'd have to find, you have to do subtracting by 180. But anyway, let's go ahead and move on to number 2, cotangent. All right. So once again, with cotangent, you guys know we need to start by doing the reciprocal on both sides. Let's punch that in our calculator and see what we get. I get negative 4.237. And then we're going to arctangent both sides to find our first answer. Let's see what our calculator gives us. And so for that, I get negative 77. Now, we don't like negatives, so we're going to add 360 to that, just like we did with secant and cosecant. We don't like negative angles as our answer because we want our answer to be between 0 and 360. So I'm going to add 360 to that to get the coterminal for it, which is 283 degrees. Okay, so there's my first answer, 283 degrees. All right, let's go ahead and move on to the next step, which is to sketch that angle. All right, so 280. Well, I know that from here to here is 270, so 283 will be somewhere like right about there. All right, so that's 283 degrees. Now I need to find the answer that is symmetrical to that, but remember, we're doing tangent and cotangent, and when it comes to tangent and cotangent, the answer that goes with it will be diagonal from it over here. Okay, so now I need to find out what is this angle. All right. Well, first of all, I'll show you the more common way that we're used to doing it, and then I'll show you the shortcut way, but let's begin. So if that's 283 degrees, let's figure some stuff out. This first piece over here would be, what would this be? So if this is 283, this missing piece right here would be, we know that from here to here, right, is 270. So if I take that away from 283, I'll be left with 13. So this must be 13 degrees here, which means that this is 13 degrees up here because of the symmetry. They're diagonal from each other. And so this angle here would be, this red one anyway, let me highlight that, will be 90 plus 13. That's one way to do it. Once again, it's not the only way to do it. There's a lot of ways you guys can arrive at the answer, but I end up getting 103 degrees. Now that's the longer way, where you just kind of find all the missing angles and add up the pieces that you need. But let me show you guys the faster way, which just involves 180. So we had 283 down here, right? I know that the other angle is up here. Okay. Now, I'm not going to add 180 to it like I did on the last problem, because that would make me go past 360. If you add 180 to 283, you're going to go past 360, and we don't want to do that. But what we can do instead is we can subtract 360. I'm sorry, not 360. It's 180. We could subtract 180 from our angle. So if you take 283 and subtract 180 from it, you get 103. So that's another way of doing that problem. So if it's sometimes you can add 180, sometimes you could subtract 180, but you have to make sure that you stay within your range if you're going to go with that shortcut method. Okay. All right. So here is another student practice for you. Actually, I think I need to change the numbers, so just a second. All right, so there you guys go. So go ahead and try those two problems, and when you unpause the video, we'll have the solutions up for you. All right, guys, so there are the solutions for that problem set, and that's where we'll call it a day. So we'll see you guys in class to practice. Have a good one.